we are perfectly clear. The purpose of tonight is for me to work through every one of these problems so you can hear it and see it. It jogs your memory. You put a little star next to the things you have to study. The purpose of tonight is not for me to teach you anything. I already tried to do that. And if I didn't do a very good job, then we have to do it one-on-one. This is not the time and place for that. Otherwise, we'll be here till tomorrow morning. So, here we go. Number one. I believe we talked about one of these on our mini review. Maybe not. I'm getting confused. We want to factor anything that factors. And then, as soon as we get everything factored that factors, we multiply through by the common denominator. So my common denominator is x plus 1. So I'm going to multiply everything by x and x plus 1. That's both sides. Now, some of you are too lazy and you do not multiply everything by the same thing. It's illegal to multiply by different things. You need to multiply everything by exactly the same thing, and then stuff will cancel. So here I have left x plus 1, x minus 3. Here I have left just minus 3x. Here I have left just plus 3, and of course 0 times anything is 0. So now I will FOIL this so that I can do some collecting of like terms. Looks like I'm going to have a little quadratic equation. Which I will solve however I want. This one does factor very easily, so I'll probably just factor it. And my answers are 0 or 5. But as with all rational equations, I'm going to look back at the original problem and notice that if x were 0, what would happen here? I'd be undefined. So that is an extraneous root, and the only answer to the problem is 5. I know we did one of these where we are evaluating a function at, in this case, x minus 2. So this is exactly the same as saying let's find f of 7. We would just take out the x's and put in 7's. We're going to take out the x's and put in x minus 2's. I will not take pity on your soul if you do not simplify properly. This is a FOIL. We are now big kids and we should know to FOIL when we have something like that. So I've got 2x squared minus 8x plus 8 minus x plus 3. 2x squared minus 9x plus 11, and that's the answer. Don't do anything with it. Don't try to factor it, solve it, anything. That's the answer. The question was, what happens when we plug in x minus 2? This is what you get if you plug in x minus 2. Then there's a part 2 to that question. Same function, but find f of negative 3i. What does that mean? Well, same thing. Take out the x's and put in negative 3i. So I'd have 2 negative 3i squared minus negative 3i plus 1. So I need to remember, okay, negative 3i squared would be 9i squared. And I squared is negative 1, so this is really negative 18. So negative 17 plus 3i is what we get when we evaluate that. And again, we don't do anything with that. We just move on. That's the answer. Oh, this is recent. Find the exact radian measure for 100 degrees. Everybody knows how to do that. We're finding the exact radian measure for 100 degrees. We say pi is to 180 as something is to 100. So x equals 100 pi over 180. which reduces to 5 pi over 9. So the answer is 5 pi over 9. Now this inequality, it's a compound inequality, there's two of them here. It could be split up, but it's probably easier just to leave it the way it is and get x by itself. That's our objective. We want to get x by itself. So what's that, 8? Now when you do that though, you got to add it to everything. And then divide by 4. Everything. So now we see our x is between 3 halves and 7 halves. You want to be on the lookout if that's a multiple choice question. The answer may look like that, but it might also look like this. Right? Because that's another way of writing inequalities. Find the exact degree measure of negative 5 pi over 6. Well, you can do this if you want to, but we haven't been doing it that way. We've done a lot of problems to find the degree equivalent of this. Pi is 180 divided by 6 is 30 times negative 5 is negative 150 degrees. So we've done a lot of problems where we've just done it that quickly. What is the domain of this function? When I say domain, you think two things. You think no negatives under a radical sign and no zeros in the denominator. This does not have a radical, so I don't have to worry about that, but it does have a denominator. So 2x plus 3 cannot be 0, which means 2x cannot be negative 3, and x cannot be negative 3 halves. So your domain is everything except negative 3 halves. If we were graphing that, which we aren't, but if we were, we'd have a vertical asymptote at negative 3 halves, breaking the picture into two chunks. All right, now we're going to solve an equation. What kind of equation is it? It's a quadratic equation. So to solve a quadratic equation, you have a plethora of options. This one does not look like it factors. So I think I'll probably just use the quadratic formula. That's easier than completing the square because I'd have a fraction here. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. 8. Now see that 4 and that 4? They do not cancel. Do not cancel those 4s. You can't cancel those 4s until there's something here to cancel, right? So let's see. What's the square root of 8? 2 root 2. Now I can do some canceling because I've got a 4, a 2, and a 4 all in canceling position. So my answer is going to end up being 2 plus or minus root 2 over 2. Now I've got a starred problem. So this review sheet is not organized like your exam. Your exam, you have the whole calculator part, and then you turn that in and take the no calculator. Or you do the no calculator part, turn it in, and then do the calculator part. These are kind of mix and match. But that's okay. 11 to the 2x plus 1 equals 8. If this had been 2 to the 2x plus 1 equals 8, I wouldn't need a calculator. I could do that one without a calculator because what's 8? 2 cubed. And I could set my exponents equal to each other and solve, right? But it's not an 8, or it's not a 2, it's an 11. So I need to get that exponent down, and the only way to get it down is to take the logarithm of it. So I'll take the logarithm of both sides, the exponent comes down. Oops. And now I want to solve for x. So you can do this however it makes the most sense to you. Personally, what I will do is go ahead and divide both sides by the log of 11. So I'll have the log of 8 over the log of 11. And then how will I get x by itself? Once I get this number, I will what? Subtract 1 and divide by 2. So the answer we should get, log 8 divided by log 11. And then I'm going to subtract 1, divide by 2. We should get negative 0.0664 as the answer. Oh, 9 is also a calculator problem. I'm going to do exactly what I just did, right? Except maybe instead of log both sides, I will ln, because there's an e in the problem. I could get the right answer doing log, but I'll ln, because what really cool thing happens when I ln, that's gone. So 7x minus 2 equals ln 10, and I'll just add 2 and divide by 7. So I'll type that in on my calculator. ln 10 plus 2 divided by 7. I got 0.6147. I'm just randomly rounding because I didn't put the directions in here. Did I make a mistake? Is that not right?
No, you're right. You said most.
All right. So now I've got this guy. And I need to find the possible rational roots and the actual roots. All right, so what are the possible rational roots? Plus or minus factors of 27. So that would be 27, 9, 3, and 1 over factors of 3. So my list would be 27, 9, 3, and 1, and then 1/3. So it would be great if that's where I could stop, but I can't because it says find all of the actual roots. So what do I need to do? Well, I got a choice on this problem. Yeah, one option is, of course, here's your list. Start guessing, right? And hoping that something equals 0. But don't forget, you can always factor by grouping when appropriate. And that one, I think, looks promising. So if I do it by grouping, I can take out a 3x squared. And I'll be left with x plus 1. And then a plus 27, and I'm left with x plus 1. So there's my common factor. So if I set those equal to 0, one of my roots is negative 1. And what are the other ones? X equals plus or minus 3i. So there are my 3 answers. Remember, this is x cubed. We're expecting 3 answers. There they are. The first one was negative 1. And the other 2 are imaginary, plus or minus 3i. Now, that means that if you didn't group it, if you started guessing numbers, the only number that's going to work is negative 1. That's the only number in that list that's going to work. But that would be okay, because you guess it quickly anyway. All right, number 11 is solving an absolute value inequality, or equation, sorry, absolute value equation. So I'm going to go ahead and just add the 7 to the other side. Now you're going to do this problem however it works for you. The only thing is, if you're going to do it correctly. So some of you go back to your first year algebra and say 4x minus 3 equals 8 or 4x minus 3 equals negative 8. That is absolutely fine. That will give you the answer, which is 11/4 or negative 5/4. Remember, absolute values are going to have two answers because this thing right here could be positive 8, it could also be negative 8, because the absolute value of negative 8 is 8. If you have a different strategy to do that problem, which I personally would not do it this way, but I know a lot of you do, feel free to do it. Just get the right answer. You just want to get the right answer. Lots of ways we could accomplish that. Find the vertex. All right, we talked about this the other day. How do we find the vertex of a parabola? That's a parabola. Negative b over 2a. So your axis of symmetry is negative b over 2a, which would be negative 6 over 6, or negative 1. Be careful, we want our vertex, so that's the x-coordinate, and then we'll need our y-coordinate, which we will find by plugging in. So that would be 3 minus 6 minus 1, negative 4. So my vertex is negative 1, negative 4. Now, this is a parabola. This is your BFF parabola, right? Your basic parabola. How is this one different than that one? What have we done? Oh my goodness, where's the vertex of this one? Where's the vertex of this one? So what have you done? You moved it left 1 and down 4, and you have also done what to it? Made it 3 times skinnier. It's steeper. It goes up faster, which means it's thinner. The bigger that coefficient, the thinner your parabola is. The faster it rises. It's called a vertical stretch. You stretched it. So it's 3 times as skinny and shifted left 1 and down 4. Okay, so now we have this, which is already factored. Okay, and it says sketch it. So in the course of sketching it, I'm going to answer all these questions. So what are the x-intercepts? Those are easy. The x-intercepts are 1, negative 4, and 5. Where's the y-intercept? How do I always find the y-intercept? I don't care what the equation looks like. Plug 0 in for x. So my y-intercept is going to be at 80. Now I'm going to sketch it. And when I sketch it, I'm going to answer that last question. What is the degree of this polynomial? Multiply it all out. What have you got? 4. That's an even number. Even functions start up and end up. So this thing starts up. What does it do when it hits this point right here that came from this 0 right here? What does it do? It bounces off. It's tangent to the curve at that point. It bounces there. It's tangent to the curve. So when it says, where is it tangent to the curve? It's tangent at the point negative 4, 0. So it goes up, grabs that point, comes down, grabs this, and what's it do when it gets here? Goes through, comes down around, what's it do when it gets here? Goes through. So there is your sketch. Number 14. I've got some polynomial, and I know his roots are these, and it says, what's the polynomial? Well, what's one thing you absolutely have to remember?
Oh, you know that.
They come in pairs. Imaginary roots come in pairs. So you're not ever going to have just 2i. You're also going to have negative 2i. So your job is to work backwards. What is the equation that if you solved it would give you these answers? What factor would have generated this? X minus 1, x minus 2i, and x plus 2i. Those are the factors that if you solve these factors, isn't this what you get? You're just working backwards. Now we got to FOIL all that together. Multiplication's commutative, associative, makes no difference, but I would definitely start here because since those are conjugates, stuff will cancel out and make your multiplication easier. So x squared plus 2ix minus 2ix minus 4i squared. The 2ix's are going to cancel, right? What's negative 4i squared? Plus 4. So that whole mess is just x squared plus 4. That has to be times by x minus 1. So that's just another FOIL. And there is your polynomial. That polynomial has those answers. Okay, 15 says I got a couple of functions and I want to make their compositions. F of g of x and g of f of x. So f is 2x squared plus 7x minus 1, and g is 3x minus 2. And I'm going to find g of f of x. Now, you'll recall, if you say that right, you can't miss it. This says find g of f of x. That means plug f of x into g. So whatever f of x is, you're going to plug it into g. So we're going to have 3 times 2x squared plus 7x minus 1 minus 2. When you evaluate a function, you take out the x and plug in whatever it is that you're plugging in. In this case, we'll plug it in 2x squared plus 7x minus 1. We'll plug it in f. So that would be 6x squared plus 21x minus 5 if I collect like terms.
Yeah.
And we don't do anything with that. Don't try to solve it. Don't quadratic formula, all that. No. It says what happens when you put f into g. This is what happens. Then it says what happens when you put g into f. That means find f of 3x minus 2. Well, didn't we already do something like that? We're going to find f of 3x minus 2. G is 3x minus 2. We're going to find f of 3x minus 2. We're just going to take out these x's and plug in 3x minus 2. So we'll have 2, 3x minus 2 squared, plus 7, 3x minus 2, minus 1. So this is a FOIL again. Make sure you FOIL it. So it looks like that final answer, and I think I forgot to do this on the answer key, so you might want to make a note of this. The final answer is, for this one, is 18x squared minus 3x minus 7. I think I forgot to put that down. Okay? Now, for number 16, we're going to use this function right here, and we're going to find the inverse. That notation means the inverse. We're finding the inverse. Oops, I just erased that. Did you get that answer? That answer was 18x squared minus 3x minus 7. Alright, so here's my function. I like to change it to a y. You don't have to. But remember, when I'm doing my inverse, my first step is to switch the variables. So it's nice to have a y in there to switch. So x equals 3y minus 2. And then I just solve for y. So my inverse is x plus 2 over 3. Now, this is probably going to be a multiple choice question, so you do want to be on the lookout. This could actually also be written as 1/3 x plus 2/3. So you want to make sure that when you're checking for the answer that you maybe recognize it in a little bit different form. Some things are able to be written in different forms. Yeah. Okay. Now write in exponential form. Oh. Was thinking 10, that's an x. Alright, why was I thinking 10 when I wrote this problem? Because I saw LOG, and I know the base on LOG is 10. So this problem literally says 10 to the x equals 5. Now, if you can do that, you can do this one. This is exactly the same thing, but backwards. Right? We do this a lot. We don't do this very much, but you can do the same thing. What's the e going to be? Look, these two are the same. So what's the e going to be when I write this as a logarithm? It's going to be the base, right? Okay, see that x right there was an exponent, so that 7 is going to be over here. Does this say e to the 7th equals x? And you might want to write log base e as ln. ln x equals 7. How much money would you have if you deposited, this is a calculated question obviously, how much money would you have if you deposited $3,000 in an account paying 2.5%? I was a little surprised when I graded your papers at the number of you that put in the percentage and not the decimal. Remember, every formula, everyone, no matter what, has to have the decimal. So 0.025 compounded quarterly for 20 years. How much money would you have? There it is. I remember my formula. You need to remember the formula. You don't have that many formulas. Remember, second semester we get a note card or a formula sheet. Not first semester because we don't have that much. So that, I'm just going to type in. Personally, I start right here, but you know, it doesn't matter. Just be careful.
We get the credit card debt formulas, we have to memorize those.
No, you don't have to memorize those, but I believe if we look on our Jack, are there any credit card problems on the review sheet? I'm talking to Jack Linehan. Have you looked at the review sheet yet, Jack?
Yeah.
Okay, are there any credit card problems on it? No. So what does that mean about the exam? Exactly. Because what did Mrs. Ford promise you? Whatever is on the exam is on the review sheet. There are no surprises. Okay, that's what I got. Hopefully you matched. All right, number 20. A box with no top must be built from a sheet of paper that's 30 by 40. Now, you will remember the other day, didn't we do a box problem? Yeah. And now here we are doing another one. It's on the review sheet. Probably on the exam. Yeah, we're starting to get this figured out. So paper's 30 by 40. We're going to cut the corners out, all that stuff. So here we go. All the questions. Write an equation for the volume of the box. The volume of the box will be 3 things times each other. What will the 3 things be? 30 minus 2x, 40 minus 2x, and x. There is your equation for the volume of the box. Why are you roaming around?
I can grab tissue.
You can. They're right up here. All right, B says sketch the equation. Now I'm going to do that on my calculator, and you need to be efficient in this. There is only one thing you don't know. When you go to set this window, there's the equation you're typing in. You've already figured that out. When you set that window, there's only one thing you don't know. Right now, you know x min is what? X min, 0. It's always 0. I don't know why I have to keep saying that. Can these corners be negative? No. So x min is 0. What's x max? 15. Half the smallest dimension. If you're taking a chunk off each side, half the smallest dimension. If that doesn't make sense to you, you need to just memorize it, okay? That's it. It's always half the smallest dimension. What's y min? 0. It's the volume. Volume can't be negative. Now, what's the only thing I don't know? Y max. Because that's the answer to the question. That's what I'm trying to figure out. I just have to make sure when I set my calculator that I have it set big enough to see the top of the hill. I need to see that. So I'm going to mess around with Y max until I get it big enough to see that picture. So what is it? Okay, I got it. Now I'm a little bit too big. I went to 5,000. And I didn't need to go that high, but that's what I just guessed. So, there's the sketch. There's the sketch. Now, I'm going to ask you what your window is. Does it have to be 5,000 up here? No. It has to be high enough to see the top of the hill, right? So there are lots of different numbers that could be. What is the maximum volume of the box? So now I go into second calc. Left bound, right bound. And I have 5.65. 66 actually, or I'll just say 57. And 3032.30. All right. Now the question was, what is the maximum volume of the box? So you have 2 numbers here, and they can both be answers depending on the question that's asked. What is the maximum volume of the box? That is your Y value. So the maximum volume of the box is 3,032 cubic inches. Now, what size would the corners be to have a box with a volume of 2,000? This volume is 3,000 right here. So wouldn't 2,000 be in there somewhere?
Do you just press Y?
So I'm going to type in a second equation. I'm going to leave that one in there. And oops, didn't want to do that. type in a second equation, y equals 2,000. And when I hit graph, I get this picture, don't I? I need this point and this point. So I'll go back to second calc, and this time choose intercept. So I'm going to get two answers. There's two places. And we're not surprised, because remember when we built our boxes, there's all different sizes of boxes we can build. So one point is 2.19. And then the other one, I start over again, got a second calc, intersect. And it's 11.8. So, oh wait, never mind. It's 10. It's 11.8 was my guess. It's 10. So I got 2.19 and 10. So the question says, what size would the corners be to have a box with a volume of 2,000, either 2.19 inches or 10 inches? Then, what size would the corners be to have a box with a volume of at least 2,000? So that means 2,000 or more. So the x values would be any x value between 2.19 and 10, because any x value between those two generates a part of the curve that's higher than 2,000.
Because you write it as interval notation as well.
You can write it as an interval, absolutely. And then F says, what is the domain of the function? Well, we already figured that out a long time ago. Your domain is your x min and max, so that would be 0 to 15. Number 21, write as a single logarithm. Before that means instead of having these three separate things, you're going to have one. But before you can start putting them together, you have to take care of this. A coefficient in front of a logarithm is an exponent. So this is ln 7 minus ln x squared plus ln y. Now, if logarithms are added, it means their numbers have been multiplied. If they are subtracted, it means they have been divided. So I have a 7 and a y that have been multiplied, and I have an x squared that has been divided. Do not put that y in the denominator. You haven't divided by that y. You have multiplied by that y. All right, now we have another sketch, but notice it's no calculator. There's no star by it. So you need to be able to sketch this by hand. All right, so what do we do first? We have to sketch it by hand. How do we start? Always, 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 we're going to start by factoring. Because what points do we start with when we sketch a polynomial? The zeros. And where do the zeros come from? The factors. So does that thing factor? Yes. We can take out an x squared. And that tells me that my zeros, or my x-intercepts, are where? 0 and 2. What is the degree of this polynomial?
3.
3. That's odd. What do we know about odds? Start down, end up. So we start down here. What do I get when I hit that point? That's x squared. That came from this factor right here. It bounces off. What's it doing? It hits this one. Goes through it. There's your sketch. That easy. Now, this particular problem, I know many of you have forgotten your test of symmetry. Your test of symmetry, for the x-axis, we change the signs on y. And that makes perfectly good sense, because if you're talking about symmetry to the x-axis, aren't you talking about going from here to here? So a positive y to a negative y. You change the sign on y. For symmetry about the y-axis, you change the signs on x, because you're going this way. For the origin, you change them both. And for the identity line, you switch y and x. Just interchange y and x. So if I do those tests of symmetry on this problem, this is my given equation. So if I change the sign on y, I would have this equation. Is that equation the same as the original one? No. No, kids, it's not the same at all. This would be y equals negative x squared plus 4. That's a different equation. Okay, that's not hard to see. It's a different equation. Now, what if I change the sign on x? Go back to the original. If I change the sign on x, I have that. Is that the same as the original equation? Yes, because when I square it, I get x squared minus 4, which is exactly the same as the original. So that one does have symmetry about the y-axis. Now, what if I change both signs? Well, then I'd have negative y equals negative x squared minus 4. Is this the same equation that I started with? No, it is not the same equation that I started with, so I do not have symmetry about the origin. And if I switch the variables, I get this equation, which is completely different, right? So what symmetry does this have? Y-axis. Now, this particular equation, I think you probably could have told me that without going through all this work. I went ahead and went through the work because I don't know what the equation on the exam is going to look like. But what shape is this? A parabola. What does that minus 4 do? Down 4. So that parabola looks like this. Can you tell that has symmetry about the y-axis? Yes. So what I'm saying is, if you know what the equation looks like, you don't have to go through all this. There's no reason to go through all this if you can tell from the equation. Some of the equations are a little bit wild and wacky. Okay. All right. So here we go. Look, we're making great time. We're half done, half done. We are awesome. Here we go. Number 24. A function is defined parametrically . A function is defined parametrically by these two equations. All right? Where's my paper that has your names on it? Okay, so everybody has put a name on it? Okay. Now we're gonna find the point where t is 0. We're gonna find the point where t is 0. Boys and girls, if you miss this, you are hopeless. No, I'm serious. We put in 0. So the ordered pair would be -1, 3. That's it. It says, let t be 0. So you put in 0, it gives you an x value and a y value. That is an ordered pair. Write the Cartesian equation by eliminating the parameter. On the work I did the other day, or on the mini review, I think, on the mini review, it said, write an algebraic representation in just x and y, or something like that. It means exactly the same thing. It means instead of having 2 separate equations, have one equation with no t's. So what do? If we're going to have one equation with no t's, we know t equals y minus 3. So we'll just plug that in. So x equals y minus 3 squared minus 1, which is y squared minus 6y plus 9 minus 1. Notice I'm foiling. So y squared minus 6y plus 8. So now I have my 2 equations. I've done some substitution. And I now have one equation that only has x's and y's. No t's. That's called a Cartesian equation. X's and y's. All right, so now I'm going to sketch it. Okay, note this is a no calculator problem. I'm going to sketch it. So, I wonder if anybody, let's back up a step. What does that look like?
A parabola.
That looks like a parabola, but what's wrong with it? The x and y are switched, which means instead of being a parabola that opens up and down, it opens sideways. So if you recognize that and put 2 and 2 together, you know your vertex is where. Now be careful. This guy's been shifted up 3 and left 1. So left 1 and up 3 is where it's been shifted. Which, oh by the way, just happens to be the point we got when we let t be 0. Yeah. Now, this is a parabola. Here's its vertex. It opens to the right. Sketch complete. Now, let's say you didn't realize that's a parabola opening to the right, which we haven't talked about yet. It's like chapter 8 or something, okay? So we'll get there, but we haven't done it yet. So you would be relying on your common sense. So let's say you have no common sense and you can't make that connection. You still have to graph this problem. You have one point already, right? How did you get that point? You let t be 0. So could you let t be 1 and get another point? And maybe -1 and get another point? And keep letting t be things to get points until you have enough to figure out what the shape is. All right, so now we're solving. Yep, we all know how to do this. This says 4 to the second equals 3x plus 1. So 16 equals 3x plus 1, and it looks like x equals 5. And then we have another logarithm equation. It says the log, that's a 3. That's, I don't know, I'm not trying to trick you, that's a 3. Equals 2 log base 3 of 8. Now, this is a different kind of equation than this. This has logarithms on both sides. You're allowed to drop those logarithms out, but not until you take care of what? The 2. just like before, you gotta take care of that coefficient. So this says the log base 3 of x equals the log base 3 of 64. So x equals 64.
Does x equal 64?
Yeah.
Yeah, just x equals 64.
X equals 64.
Wait,
That's the answer. The logs drop out. Alright, we had one exactly like this on your test that you took over this material. It says sketch. Notice it's not a calculator problem. So you need to rely on your knowledge of your BFFs, because this is what?
Exponential.
An exponential. And we know that exponentials look like this, right? Now, what does that plus 2 do? Moves it to the left 2. So every point comes over 2 units. Every point. So we end up with that. Every point. Now, does this curve have any asymptotes? Y equals 0. Does it change when I put that exponent in there? No. No. The only way the asymptote's going to change is if I said graph y equals 3 to the x plus 2. Because what does that do? That raises it up. So that asymptote would go up to 2. Going sideways doesn't change the horizontal asymptote. All right, David invests this money at 4.5% compounded annually. How long will it take for him to have 1, 2, 3, 4? So 1, 2, 3, 4 equals 987. 1 plus 0.045. What's n in this problem? 1. Why is n 1? Annually. That means once a year, right? So we're going to solve this. Notice the variable is an exponent, right? So I need to get it down, and the only way to get it down is to use a logarithm, but I can't do that until I get rid of this. So 1, 2, 3, 4 over 987 equals 1.045 to the teeth. Now I can log both sides, or ln both sides, no difference, no advantage one way or the other. So the log of 1, 2, 3, 4 over 987 equals t times the log of 1.045. So this is what I'm going to end up typing into my calculator. And wow, I got 5.074. That's not very long. It's only going to take 5 years, 5.074 years. How long will it take 543 bacteria to grow into a population of 8901 bacteria if the population increases 2.3% per day? Now, this is a PERT formula, and remember, in the PERT formula, T can have any time unit. So when it says it increases per day, you're going to go ahead and just put in 0.023, and then your answer will be in days. We don't make any adjustment in the formula for days. We just plug it all in. So we want 8901 equals 543 growth rate is 0.023 t. So this looks a lot like the one we just did. The variable is the exponent. Before I can get it down, I need to divide. And since the problem has an e in it, since I used my PERT formula, I'll ln both sides. And that will wipe all this out. So ln 8901 over 543 equals 0.023t. So I'll just divide ln 8901 divided by 543. I'll just divide that by 0.023. And it looks like, now this is going to take a while, 121.6 days. All right, if Nate is 1 minute late, he gets 1 detention. If he's 3 minutes late, he gets 4. If he's 4 minutes late, he gets 11. Write a quadratic equation using the quadratic regression capability on your calculator. All right, so stop right there. I'm going to do a regression, which means I have to put data into my calculator, right? So what are the data points that are going into my calculator? What are my lists, my x's and y's? What are they? What's the first one?
1,
1, 1. And then, boy, when that goes off, doesn't it make a difference? I get so used to that noise when it goes off, it's like, ooh, it's quiet. 3, 4. And 4, 11. And that's it. Those are the only points I'm going to put in. Now, listen to me. You do not have to go through all of the stat plot rigmarole. You don't need to do that. The only reason we ever graph our data points is to see what shape it is, right? Because we need to know what shape it is in order to know if we're doing linear regression or quadratic regression or cubic regression or whatever kind of regression we're doing. There's no confusion here. It says quadratic regression. So put your data points in, stat edit, put your data points in, and then go back in to stat calc and do quadratic regression, and it should give you y equals A, B, and C.
1.833.
Can you make that a fraction? Or not?
No.
All right. 1.833 x squared. What's B?
Negative
5.833 x. And what's C?
5.
Just 5?
Yeah.
All right, so there is our quadratic equation that represents this data. How many detentions will Nate get if he is 5 minutes late? So in other words, what if x is 5? What will be the y coordinate?
So plug in 5.
I just plug in 5. So yeah, I'm going to need a calculator to do that. And I'll round it off, because obviously we can't get fractional detentions. Did you get about 22?
Yes.
21.66 is what I got. Okay. What is the minimum number of detentions that he can receive? Now, before you start freaking out, what shape is this if you graph this?
Parabola.
A parabola.
So we'll go back down.
Opening up. What can you tell me about the minimum of a parabola opening up? It's its vertex. And how do we find the vertex? Negative b over 2a. So our vertex is going to be actually 5.833 over 2 times 1.833. Oh, wait a minute. Forgot my decimal point. That made a bit of a difference. About 1.59. Now, I totally made up this problem. That answer doesn't really make sense because you've already told me he can get 1 detention. But, okay, so forget the practical application of the problem. Do you understand why I found the vertex? I just said minimum.
I got 5.34.
Remember, when you divide by 2 things, they have to be in parentheses. Try it again. I'm pretty sure I'm right. If you don't use the parentheses, what happens is you divide by 2, but then you multiply by 1.8, and that isn't what you want to do. You want to divide by both of them. Okay, so keep in mind, you do not need to stack plot if the problem tells you the kind of regression that you are doing. Listen to me again. You do not need to stack plot if the problem tells you it's cubic regression, or it's linear regression, or it's quadratic regression. You don't need to draw it. You just need to get the data in and hit the regression. Okay? All right, number 30. Consider the exponential function. We've already had it graphed today. Now, I want to remind you, some other sheet we looked at said consider the square root function, right? There's going to be one BFF on the exam that you're going to need to be able to talk about. So you need to know your BFFs. You need to know them anyway. So if you've forgotten them, make yourself little flashcards or something and get the basic shapes down. All right. Domain.
All reals.
All reals. So you can either write all reals or you can say negative infinity to infinity. It doesn't make any difference. Now, I say it doesn't make any difference. If it happens to be a multiple choice question, you're going to want to know that means all reals, right? Okay. Range. 0 to infinity. Not including 0. There's an asymptote at 0. Continuous. Yes, there are no breaks in this curve. It is a continuous curve. Does it have any asymptotes? Yep, just talked about it. Y equals 0 is its asymptote. Increasing or decreasing?
Increasing.
It is an increasing function. It increases the entire way. Bounded.
Bounded below.
Bounded below by y equals 0. End behavior. That means what happens as you go to the left and what happens as you go to the right. That's your end behavior. So what happens as x, as we go to the right, my pencil's going up, down, staying the same, what's it doing? Up. So that one is positive infinity. Now what about as I go to the left? What's my pencil doing? Getting closer to 0 from the top. So I put a little plus sign on that, which distinguishes it from something that would look like this, right? That's approaching 0, but it's approaching from the bottom. All right, number 1, find all the asymptotes. All right, so here we go. Find all the asymptotes. That would mean vertical, horizontal, and slant. Okay? Vertical. Where's my vertical asymptote? There is one. Where is it? X equals 4/3. Vertical asymptotes happen when the denominator is 0. How about horizontal asymptote? The powers match, boys and
So
girls.
it's 2/3.
So y equals 2/3. There will never be a slant asymptote unless the power on top is bigger. As long as the powers match, or the one on the bottom is bigger, you're going to have a horizontal asymptote. Speaking of which, 3x minus 8 over x squared minus 4. Vertical asymptotes, there are 2 of them. X equals 2, x equals -2, because that denominator factors, right? Where do vertical asymptotes come from? Whatever makes the denominator 0. Now, the powers do not match. However, the one on the bottom is bigger, so the horizontal asymptote is y equals 0. Find the symmetry of this function. This is a little bit harder function, so I'm going to do my tests real quick. All right, this is not a calculator problem. None of these are. This whole thing, they're all not. So here we go. To do the x-axis, I change the sign on y. That is not going to give me the same equation, right? Y-axis, change the sign on x.
Yes.
Nope, it's not. It's going to give me -x squared plus x, which is not the same as the original. I am comparing it back to the original. Identity line, that no way. That is not even close to the same equation. And the origin, I changed the sign on both. Now, I need to clean that up to the side. Uh-oh, what happens? It cleans up to be the same. So I have symmetry about the origin. A vocabulary word associated with that is odd. My function is an odd function if it has symmetry about the origin. If it has symmetry about the y-axis, which our earlier one had, it is even. Okay, everybody knows how to do this. 2 pi over 3.
20, 120.
120. So I'll draw 120. Drop my perpendicular. My reference angle is 60. Root 3, 2, and 1. Anything negative, I'm not in quadrant 1.
The negative
The 1 is negative. I want the sign. Opposite over hypotenuse, root 3 over 2. Find the y-intercept. All right, we talked about this the other day. How do we find the y-intercept? Plug in 0 for x. Does it matter what kind of equation I have? No. I plug in 0 for x. Uh-oh.
Would A be undefined?
A, there is no y-intercept. There's an asymptote at 0, so you're not going to cross the y-axis. It's undefined. There is no y-intercept for problem A. You cannot put in 0. How about B? -3 over 1, which would be -3. How about C? What's 3 to the 0? So we have 12 over 9, which reduces to 4/3. So your y-intercept is 4/3. Okay, what about D? How do we find a y-intercept? We let x be 0. So if we let x be 0, we have this, which means t equals 3. The y-intercept is a y value, though. So how am I going to get a y value? I'm going to let t be 3. So my y value is 11. 3 squared plus 2. And E? 4 times negative 3. So the answer is negative 12. Number 5, find the vertex. Well, A is pretty easy. The vertex of A is negative 1, comma, negative 1, comma, negative 3. In problem A, everybody look at 5A, aren't we going left 1 and down 3? Now, B is written just a little bit differently. Could I add the 3 back to the other side?
Yeah.
So that it looks like that?
Mm-hmm.
And if it looks like that, then it's just like A. So the vertex would be at negative 5, comma, 3. Left 5, up 3. And then C, to find the vertex, we'll have to do what? Negative B over 2A. I got 3 halves. Is that the answer? No. The vertex is an ordered pair, and I know x is 3 halves. I'll plug it in, and oh, by the way, this is a no calculator problem. So 2 times 3 halves squared minus 6 times 3 halves plus 1. What's 3 halves squared? 9/4. And 2 times 9/4 is 9/8. Minus 9 plus 1. So 9/8 minus 8, which is 9/8 minus 64/8. Negative 9 plus 1 is negative 8. 64/8. So negative 55/8. So that's my y coordinate. So 3 halves, comma, negative 55/8.
How did you get 9/8?
Oh my gosh, yes.
Right, I was gonna-
Yes. Yes, indeed. 9 halves, thank you. Yes, indeed, it is. Thank you, thank you, thank you. So 9 halves minus 16 halves. So that would be negative 7 halves. Is that better? All right. Okay, here we go. Find the remainder. We talked about this the other day. There are a couple of different ways you can do it. One way is to just plug in negative 2. And the other way is to actually do the division. In this case, it makes no difference. I don't know that there's an advantage one way or the other. You do want to be careful when you're doing your division that if there are any things missing, any powers missing, that you put in zeros, but it doesn't look like I have any. So it looks like I got 9, but double check that since I'm prone to errors here. So if I do the division, I get 9. If I plug in -2, I should also get 9, since that's the remainder. Yep, I do. I get 9. So it doesn't matter which way you do it. If the problem had been find the remainder of x to the 40th plus 5x minus 8 divided by x minus 1, if that had been the problem, then you probably would want to just plug in 1 and not do the actual division. Find the intervals where f of x is decreasing. Decreasing means going down. So this thing appears to be going down from this point to this point. I'm going down. Would you agree with me?
Yes.
So the decreasing intervals, we're going left to right, so they're x values. We're going left to right. So from -1 to 1, if I sketched it accurately, is where I'm going down. That would be my decreasing. If it had asked for increasing, there are 2 of them. It would be from here to here, I'm increasing, right? So -2 to -1. Or from 2 to 3. Is that 3? That's where I'm increasing. Decreasing means going down, increasing means going up. That's it. It's that simple. And finally, given that angle C is an acute angle, what does that mean? Less than 90, first quadrant, everything positive. And the tangent is 1/3. Find the sine. Well, I'm missing something. What am I missing?
Your hypotenuse.
I'm missing the hypotenuse. So the hypotenuse would be the square root of
Not 11.
9 plus 1. Even I can do that one. That would be the square root of 9. So what's my sine? My sine is 1 over root 10, which I'll rationalize to root 10 over 10. Okay? You just took the exam. So you know what you need to study. Hopefully you've been making little notations. Yeah.